Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we are talking about why do we use the formulas that we use for finding out the surface area and volumes of a cuboid. So in the previous episodes we talked about different shapes and what formulas do we have to use, and in the previous episode we talked about cube and why do we use the formulas that we use for finding out the formula of cube, the surface area of cube. So if you haven't checked it out, then recommend checking those episodes if you have any confusion in those topics. So in this episode, we are talking about why do we use the formulas that we use for finding out the surface area or volumes of a cuboid. So now, let me just draw a cuboid real quick. So let's say this is a cuboid. Now it looks more like a cube, but let's take this as an example. So for example, if we take this, we obviously have some measurements. The first one obviously is the length, which is basically this measurement, which we can call as length, or this is also something we could call as the length. So let's take this as length, and now this one, so this could also be measured as the height, and the side part over here we could use to measure it as breadth. So we have the three measurements that we use. So length, we have breadth over here, and we have height. So to find out the area of an oval rectangle, you obviously need to use the formula length into breadth for finding out the area of a single rectangle. So for example, the reason we use the formula, the area of rectangle, is because we need to multiply the measurements. So for example, over here we have the length, or let's take this, we have the length and the height. So for example, here you have the length and you have the height. Over here you have the breadth and you have the height. Again over here you have the length and height, breadth and height, and on the top you have length into breadth and length into breadth. So to put this into perspective, we basically have two sides which are basically length into breadths, which is the top part which has length, which has the length and breadth when you compare it in this way. So you have two sides which resemble the length into breadth. Then you have two sides which resemble length into height. So for example, you have the length into height, and so you have this side and this side. So you have two length into heights. And finally you have two sides which resemble the breadth into height, or height into breadth. So we have the breadth and height, which are the smaller parts. So we have two breadth into heights. So we cannot use this long formula as a formula, so we obviously need to shorten it down. So now what we could do is we could take most of the stuff as a common. So let's take the common in this, which is common in this, or what we could do is we could take each term. So for example, let's take L into B and L into B. So we have 2L into 2B plus we have L into B, so 2L, L into H, so 2L into 2H plus 2 breadth, so 2B into 2H. So this is the form that we now get, which is much more simplified form of the surface area. So now we could take 2 as common in all of this, so we can remove all 2's. So we get 2 as common, and LB, so L into B plus L into height, LH plus breadth into height, or BH. So this is the final formula that we use for finding out the surface area of a cuboid. So this is how we can find this out. Let me just recap it once again. We have three measurements: length, so we have length, we have breadth, and we have height. So since we have two sides which have length into breadth, one side and the second side, we have two sides which have length into height, which is this side, and we have two sides which also have height into breadth, so this side and this side. So we get this, and by simplifying it we get the formula of 2 into LB plus LH plus BH. So now that we have understood that, let's talk about the curved surface area of a cuboid. So now let's talk about the curved surface area of a cuboid. So for example, now let's say we take the same example which we have here, but since the curved surface does not involve the bases, we do not have the breadth or length. So now we are left with length into height, length into height, and breadth into height, breadth into height. So now that we have all of this left, we can put them again in a formula. So 2L in 2L plus 2H. We can put all that, and by simplifying this again, we get 2LH plus BH. B stands for width. That is a topic for another day. It's breadth and width basically mean the same thing. So we get this formula. Now one thing you will notice is that H is also common in both of these. So you can also take H as common, so it will become 2H L plus B or W depending on what you think. So this is the curved surface area of a cuboid. So now that we have talked about the total surface and the curved surface area, now let's talk about the volume. Now a volume is pretty simple. We basically need to multiply all of those factors, measurements, because that is how it works. We have talked about it in the previous episode cube, but it's also basic surfaces and volumes. But basically, the formula for finding out the volume of a cube is length into breadth into height, which is basically the equal to the one that we see in cube, but basically it means to multiply the length into breadth into height. So that is kind of the simple way on how you get the formulas of cuboid, and hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so don't miss out any new videos. And that's it folks, and see you in the next one. Bye bye.